Hello everyone. In this video lesson, I will be discussing the applications of trigonometry. And to be specific, I'll be discussing the applications of trigonometric functions for right triangle. I am your teacher, Mr. Mark Anthony B. Laroya. So this is a right triangle. A right triangle is a triangle wherein one of its angle is a right angle. So here, we can name this triangle as triangle ACB, where angle C is our right angle. Based on our given, angle B is equal to 50 degrees, and its opposite side, which is side B, is equal to 7. Here, sides A and C are unknown. So let us now solve for the length of sides A and C using the different trigonometric functions. So let's start with solving A. Side A, with respect to our angle B, which is a given, side A is adjacent side to angle B. So we have adjacent side and an opposite side. Therefore, we can use the trigonometric function tangent to solve for A. So, solving for A, we have tangent 50 degrees is equal to the opposite side, which is 7, over the adjacent side, side A. So, solving for A, we have now A is equal to 7 over tangent 50 degrees, and this will give us a value of 5.87. So the length of side A is 5.87. Now, solving for C, if we take a look at our triangle, side C is actually our hypotenuse, the hypotenuse of our right triangle, the longest side of our triangle. So, it involves here the hypotenuse and the opposite side. So, opposite side and hypotenuse, we can use now the trigonometric function sine. So, we have now sine B is equal to the opposite side, which is 7 over the hypotenuse, side C. Substituting the value of our angle B, which is 50 degrees, we have now, for C, it will become C is equal to 7 over sine 50 degrees. And the value now of our C will be equal to 9.14. So, as you can see here, the value of this side, hypotenuse C, is 9.14, will be the longest side for our right triangle. So let us now talk about this time the angles of elevation and depression. The term angle of elevation denotes the angle from the horizontal upward to an object. An observer's line of sight would be above the horizontal. The term angle of depression denotes the angle from the horizontal downward to an object. An observer's line of sight would be below the horizontal line. Let's say we have a ball and a post. Both are lying on a horizontal plane or surface. With respect to the ball, to the top of the post, we form an angle. With respect to our ball, it forms an angle of elevation going to the top of the post. And then, with respect to the horizontal line on top of the post, it now creates what we call the angle of depression. Now, let us use the same example to solve a problem. Let's say, again, the ball creates an angle of elevation with respect to the top of the post, and it is equal to 40 degrees. And then the ball is 5 meters away from the post. The question now is, what is the height of the post? So as you can see here, it forms a right triangle. So the angle of elevation will be our given angle. The distance between the ball and the post, the 5 meters, is the adjacent side with respect to the given angle. And the unknown height of the post is the opposite side of our given angle. So therefore, we can use the trigonometric function tangent to solve for the height of the post. So we have now tangent 40 degrees is equal to the opposite side, which is the height of the post, over the adjacent side, which is equal to 5. So the height of the post is equal to 5 times tangent 40 degrees, or equal to 4.20 meters. This is the height of our post. For our last example, we have a word problem. City A is just 4 kilometers away from City B. Just a kilometer and a half above City B, a UFO appeared. If people from City A can also see the appearance of the UFO, what is the angle of elevation of City A to the UFO, or with respect to the UFO? So let us illustrate the problem. So we have the two cities, City A and City B. And above City B is the UFO. City A and City B are 4 kilometers apart, while UFO is just a kilometer and a half above City B, or that is equal to 1.5 kilometers. We are asked to get the angle of elevation of City A with respect to the UFO. So this is the angle of elevation. If this is our angle, therefore, the distance between City A and City B will be our adjacent side, and the height of the UFO above City B is our opposite side. And again, we can use the trigonometric function tangent to solve for the angle of elevation. So, we can now solve for the angle, that is inverse tangent of the opposite side 1.5 kilometers divided by the adjacent side 4 kilometers. So this is now equal to, angle is equal to 20.56 degrees. So this is the angle of elevation formed from City A to the UFO. And that is how we use the trigonometric functions for angle of elevation and angle of depression. So thank you very much for watching this video lesson, and I hope you learned something new about the application of trigonometric functions in our daily life, or how we use the concept of trigonometric functions. See you again next time. God bless.